Assalamualaikum and good afternoon to Dr. Azazi. Today I am Solihah Binti Adenan and my group members which is Nurul Najeehah binti Sani, Aliza Nadira binti Rosli and Muhamad Syariz Shazwan bin Amran, which is we are from group 10, would like to present about liquid penetrant testing. Now I would like to present about the fundamental of liquid penetrant testing. Liquid penetrant inspection, also known as dye penetrant inspection. It is developed in the early 1940s. The function is to detect flaws on the surface of material. Liquid penetrant inspection is a non-destructive test method which does or harm the sample of part being inspected. The test is very effective in detecting porosity, crack, fractures, lapse, seams, and other flaws that are open to the surface of the test piece and may be caused by fatigue, impact, quenching, machining, grinding, fogging, burst, shrinkage, or overload. It is often used on lots of machine parts, as well as weld mats, manufactured product, casting, fogging, and other items that will place into service. Liquid penetrant inspection can be used successfully or on non-porous and fairly smooth materials such as metals, glass, plastic, and fried ceramics. The test is named for the liquid colored penetrant that is applied to the sample during test in order to make a surface flaws more visible. The penetrant comes in two types of liquid visible dye, colored red and fluorescent dye, colored green-yellow. Fluorescent penetrants also classified by sensitivity levels ranging from 1 through 4, with 4 being the most sensitive for detecting the finest flaws. Penetrants can be washable with water, removable with solvent, or require treatment with an emulsifier that is lipophilic oil-based or hydrophilic water-based. The idea of testing related is such as below. First, we have to surface the preparation, penetrant application, penetrant dwell, access penetrant removal, developer application, indication development, inspection, and clean surface.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Syariz Amran. Now I will explain about the procedure to conduct the liquid penetrant testing. First of all, the first step is surface preparation. All surface to be examined should be clean, dry and free of soil, oil, grease, paint and other coating, corrosion product, scale, smear metal, welding flux, chemical residues, or any other material that could prevent the penetrant from entering discontinuous, suppress dye performance, or produce unacceptable background. Next, the second step is penetrant application. Penetrant should be applied by spraying, dipping, brushing, or other method to provide coverage as required. The third step is penetrant removal. There are a lot of processes. One of them is method air process. Water, washable penetrant should be removed with a manual or automatic water spray, or a manual wipe, or an aggregated immersion wash. Next, the fourth step is drying. The component should be dried prior to the application of dry developer, known as waste developer or examination without developer. Next, the fifth step is developing. Unless otherwise specific, developer should be utilized for penetrant examination. That have a lot of developers such as dry developer, known as aqueous developer and aqueous developer. Next, the sixth step is examination. Components should be interpreted before the maximum developing time and if required by specific procedure, monitor periodically during the developing time. Next step is post-cleaning. Components should be cleaned after examination to remove developer and other examination material residues if these are detrimental to subsequent operations or other components' intended function. Next, quality control provision. This section provides the control necessary to ensure that the penetrant system, material, and equipment provide an acceptable level of performance. And the last step is marking and identification. Components successfully passing the penetrant examination should be identified and marked as follows: marking, impression, stepping in stepping, D'ing, laser marking, vibro engraving, pinning or etching, and other identification, and the last one is symbol. So this is the process flowchart to easy understand for this procedure. Next, I will explain about advantage and disadvantage liquid penetrant testing. The most common advantage of penetrant testing are presented. First, highly portable. Second, high sensitivity to small defects. Third, applicability to the most materials. Fourth, relatively fast inspection and low cost. Fifth, applicability to complex geometries. And the last one is limited technical knowledge, being that the defect become visible at the surface. The most common disadvantages of penetrant testing are presented. First, applicability to surface defect only. Second, porous material limitation. Third, pre-cleaning and post-cleaning required site. Fourth, accessibility to surface required site. Fifth, sensitivity to surface condition. Sixth, process step interdependent from start to end. And the last one, chemical waste and handling requirement. So that's all from me. Thank you.
Is Nurul Najeehah Binti Sani. I would like to explain further about the innovation or improvement NDT to the latest technology. The introduction of robots trained in automated liquid penetrant system in NDT have already allowed companies several competitive advantage. The most important, this new technology will bring the benefits such as robots and automatic version system have recently been applied in the non-extractive industry whose function to support the operator in the vision of the indication possible defect by automatically identifying the indication person in charge of the quality control.
Assalamualaikum, my name is Aliza Nadira binti Rosli. I will present about the related project done by industry and research. First is the A++. In 2003, A++ incorporated LGAI, the General Laboratory for Testing and Research. And second is the research about the International Journal of Advanced Research in Engineering and Technology, IGART. Experimental study of defect in stainless steel 316L Wellman's route liquid penetrant test for surface. The picture below shows that the logo of its industry and research. In LPT is one of the most widely used non-destructive testing methods. LPT is based on capillarity or capillary iteration, where a liquid is able to flow into narrow spaces without the assistance of or even in opposition to external force such as gravity. The material process and procedure used in liquid penetrant testing are designed to make the result of this capillary action visible and capable of interpretation. Liquid penetrant testing is an effective means of locating and determining the severity of surface discontinuities in materials, including those that are not visible to the naked eyes. So, A++ use only quality product from the industry's top suppliers such as Syariz and Manaflux. Also have laboratories available that can provide testing on products shipped to these locations. The procedure comply with ASNT and ASTM requirements. Also have a certificate level 3 technicians on staff to provide support and guidance as well as developing new procedure when required. Target customers. LPT can be used to locate and evaluate defect through an item life cycle such as a manufacturing defect, open the surface such as cracks, lack of function porosity, gas pockets, cool shuts, inclusions, hot tears, and gas holes. LPT can also detect in-service discontinuities such as fetish cracks, HIC, SOHIC, SCC. Early identifications of in-service discontinuities means that outage can be planned and executed properly rather than as an emergency. This testing method is used in variety of industries such as aerospace and food processing. In part research, the samples taken for these studies are extensively used in aerospace and industries applications. The dimensions of fabricate samples of stainless steel are 30 minus by 40.3 minus by 0.9. This sample is subjected to gas tungsten arc welding GTAW. During welding, artificial defects are incorporation by altering the weld parameters. The profile of weld defect is studied by using basic non-disruptive testing technique. Defects which are open to surface and subsurface defect up to 6 mm depths are detected by liquid penetrant test LP. These evaluation studies through non-destructive testing techniques are much useful for structural health monitoring of the weldments. Detection of surface imperfections is carried out by using liquid penetrant test in a controlled defined manner on mild steel alloy aerospace material of thickness in 3 mm. Material used during investigation. The following are the different materials used in a liquid penetrant testing, such as a workpiece, specimen 1 and specimen 2, cleaner, penetrant, developer, lint-free cloth, and ultraviolet light for fluorescent method.
Conclusion, not all NDT equipment is created equal. Some instruments are indeed for laboratory work, others for rugged work in the field. Choosing the right NDT manufacturer is as important as finding the right method. Manufacturer can not only provide equipment, but also training, support, and advice. Those with the deep industry experience have the institution knowledge and experience needed to handle the new or tricky inspection issue. Partnering with a trusted NDT manufacturer can provide not only effective NDT equipment, but also invaluable peace of mind.
This is the references that we refer for the assignment. I appreciate you all's keen interest in the lecture, which has taken my team and I hours to prepare for. You folks are simply the best. Thank you for listening to our presentation. Assalamualaikum.